Hello guys, a very happy morning to all of you. And guys, now we are just going to see the awesome, it means topic under subject that's been given in the manufacturing technology. Okay, so in the manufacturing technology, we are just going to see one of the most important subject that is called as welding. Okay, see why the it means especially in my point of view, welding is so much important. Okay, so it means welding. Okay, without wasting time, let's get started. Okay. So welding is a process by which two materials, usually metals, are permanently joined together. That's it. So it is mainly because of it means there is a two type of thing in has been cohesion as well as adhesion. But in the welding, mostly adhesion as well as the cohesion is so much important because if sticking of same it means cohesion means two same materials attract each other. Adhesion means two different materials attract each other. Okay. So permanent joined together by coalescence and which is integrated by the combination of temperature, pressure as well as metallurgical condition. Okay. So but mostly you can see mostly in pressure friction it means friction welding happens, but it is a solid state welding. Okay. Friction welding friction welding comes under the category of solid state welding. Okay. So you can see only in the red hot condition. Okay. So next one is metallurgical. Why the metallurgical is so much important? Because the molecules might be different. For example, this is copper and this is nickel. Like this, the molecule will be different. So the diffusion should occur properly. Okay, you can see the molecule structure and you can see this molecule structure of this nickel. So the diffusion is also most important thing for the entire welding process. So sometimes high temperature without pressure will be given. Okay, then also if you example the arc welding, that high temperature only will be, there won't be any kind of pressure. And next one, high pressure with no increase in temperature, that's called as explosion welding. It means only the pressure will be, the temperature will be so much minimum, so explosion welding. And sometimes it means explosion welding, like sometimes you take the candle and you just light up the candle and you just move the it means you just move your finger over the fire. So does the fire affects our hand? No. The same kind of thing only it happens in the welding process also, especially in the explosion. Instead of time, the pressure will be so much tremendously high, the temperature won't be that much in a very efficient way. Okay, I think so you're getting the point. So second is it is similar to solid state welding. Every time guys, in the entire welding process the heat will be, okay, without heat none of the, it means without heat none of the process, especially in the welding, doesn't work. Okay, heat is that, but it is very, this is not a thing. Okay, but okay, I think so you can understand welding means definitely heat should be, that's it. So next one, welding is a positive process. Positive process means in this welding we are just adding the materials. Okay, next one is machining, means it is negative process. Negative process. Okay, it means we are just removing, we are just taking, it means we are just removing the extra material that's been present there. Okay, next one is forming or gases is no material, it means zero process. Okay, it means no material is being removed or no, it means no changes occur, just we are just pouring the molten metal and we are just getting the liquid shape of the product. Okay, that is called as casting. Okay, I think so you're getting the point. So the next thing is you can see required for the high quality weld. Example, a source of satisfactory, yes, definitely heat is most important, as well as the pressure is also so much important. And a mean of protective, it means protective or covering the metal, yes, definitely. When it means guys, it's so simple guys, whenever you just it means how to say, means whenever you just heat a metal, you just leave it as it is. Sometimes after that what will happen, the oxidation will be so much rapid because the heat attract more amount of oxygen. Okay, so we need to protect, it means we need to cover the entire area with any kind of, it means noble gases. So next one, the it means a harmful metallurgical effect is also there. So while fusing, it means a tungsten iron. So tungsten scheduled down and iron scheduled up, so no diffusion occurs. Okay, because of the density also the welding doesn't occur properly. Okay, so I think so you don't know about the Samudra and DRDO project. In the Samudra and DRDO project, titanium is being especially used. Suppose if we just add the titanium as well as to other kind of metals, the diffusion should be so much proper. Okay, if diffusion doesn't occur, means it will lead to a lot of problem. So you can see advantage of welding. So release joints from the release is definitely release. So next one, it means checking distortion of the workpiece. Large number of metals and alloy can be, it means similar as well as non similar can be, just definitely C is the option. Okay, so the next kind of thing is gas welding. Okay, so first of all, before beginning that, I'll just show how the welding, especially the friction welding, is working. Friction welding, I think so you're getting seen there. So you can see this two materials, see, one is being constant, other one is being rotated. Okay, so while it is being rotating, you can see how much amount of heat is being produced, and you can see how much the friction is been there. Okay, you can see other in case scenario they are just leaving as it is. Okay, this is friction welding, and at the end you can see they are just removing the entire chips. Oh, see how perfectly they are just taking each and everything. So now we just got the required shape. Okay, now you can see each and everything is perfectly finished. Okay, so this also comes under the category of friction welding. Okay, I think so you're getting the point. So you can see, so next one is you can see about the gas welding. So gas welding you can see, yes, this one I just wanted to show to you. Tower is not available. Okay, so next one you can see gas welding. Gas welding is also so much important thing, guys, especially here we use lot of acetylene gas. Okay, especially in the gas welding. Gas welding. So I think so you can see this one. So this is example of gas welding. You can see the gas is being used to burn each and everything, and by using that time we will just it means make the each and everything as welding. So you can see the gas is being present here. Now we will just add a bit of other material and we will directly weld the gas. Okay, now we can see gas welding. See, you can see the white torch as well as the it means black one. You can see the welding occurs it is. Okay. Okay, you see, wow. See, this is the thing that's the being welded. Okay, I think you're getting the point. See, oxidation welding, and you can see, guys, in this thing, you can see the white cone, little bit of white cone is there, as well as the blue flame is also there. So, in this entire thing, the white cone and the blue flame is so much important to look upon each other. You can see this code is so much important. Okay. Okay. So in the gas welding, especially you can see this is especially the outer frame is called as blue flame and the inner thing is white flame. Okay, white cone, and leads to melting. This white cone leads to the melting of entire workpiece. While melting, we add the film definitely, and the blue flame it's like a pre-heat condition. It just heats. It leads to red hot state of the work. Red hot state. Okay, it leads to red hot state of the workpiece. No melting of the workpiece in the blue flame. Okay. Generally, the blue flame is around 1200 degrees Celsius and the white flame is around 3000 degrees Celsius. Okay. So in that also there are certain kind of other kind of things. Okay, you can see this one. You can especially see this one, oxy fuel gas welding. Heat source with the flame produced with combustion of the fuel gas as well as oxygen. So oxygen just ignites the, it means extra amount of the fuel. It means while you are just burning the fuel, the oxygen ignites it. It means it gives a lot of other reactions also. So it has been, it means largely been replaced by other process and an arc welding like. Okay, but it is still popular because of its portability and low cost capital investment. Okay, definitely arc welding is not concentrated and it is distributed. So gas at a particular, and you can see constructed welding. So acetylene, you can see acetylene is the principal fuel of gas employed. Okay, acetylene is the principal fuel of gas employed. So combustion of O2 and C2H2O, and in the welding torch produces a temperature of 2 stages definitely. So here in this, guys, in the gas welding we generally used as a kind of thing called acetylene. Okay, by acetylene as well as by the oxygen we are just burning each and every substance. Okay, and suppose means some people might ask, okay, why we can't burn any kind of other thing using the gas, it means the LPG gas. So instead of using LPG gas and CNG, it means compressed natural gas, why we use C2H2, it means acetylene, because LPG and CNG reaction occurs in only one stage. Okay, but C2H2, it means acetylene gas reaction occurs in two stages. You can see C2H2 plus of oxygen occurs faster reaction, and LPG plus of oxygen and compressed natural gas plus oxygen does not react so much faster. Okay, and the velocity of the, it means compressed natural gas as well as the LPG gas, it is literally so much lesser. Okay, C2H2 plus of oxygen gives 2CO plus of H2O plus of heat. Okay, so you can see occurs at the near tip of torch. So next thing is one thing, it means two stages I just told. One thing at the cylinder itself one stage is being occurring, and second one while just going to the atmosphere each and every reaction is occurring. Okay, C2H2 plus of oxygen equal to 2CO carbon monoxide plus of H2 plus of hydrogen plus of heat. Okay, but this heat is used to melt the substance. So you can see next CO and next carbon monoxide and hydrogen goes out. While it's been goes out means this also leads to reaction, and the carbon monoxide reacts with the oxygen to convert into carbon dioxide plus heat, and hydrogen plus of it means oxygen goes and it forms water, it means water vapor. So this, it means this carbon dioxide, this, and as well as the it means the carbon dioxide as well as the hydrogen, sorry, carbon monoxide as well as the hydrogen, that forms carbon dioxide as well as the water vapor. This creates a, it means blue flame. Okay, I think so you have seen about the video. So while the blue flame is occurring due to this kind of condition only. So I think so you can see this one. So why not LPG? Because oxy, it means oxygen as well as acetylene flame, literally how much degrees Celsius you can see, more than 3000, but oxygen LPG and oxygen CNG literally produces less than 3000 degrees Celsius. For welding, high temperatures is required for each melting of each and every substance. Okay, so next thing you can see LPG and CNG are broader and less intense. So you can see flame carrying, acetylene produces neutral flame, yes definitely, and LPG produces more oxidizing and as well as cause porosity and pure fusion and weak welds. So heat distribution you can see in the acetylene process, it is narrow inner cone, okay, with high intensity, but in LPG and CNG it spreads out. Okay, gas supply, this one I will just explain to you. Okay, so I think so you are getting the point, guys. So you can see here, it means this one C2, it means you can see here C2H2 and plus of oxygen gives carbon dioxide, carbon monoxide plus well as heat, plus of heat as well as the hydrogen. You can see if 22.4 liters been used and as well as the oxygen is being used, you can see how much it means requirement of each and everything comes out. Okay, so 1 mole, 1 mole, so here 2 mole and this is 1 mole. So you can see this one is just Avogadro's number 6.023 into 10 power 20. This is just a 1 mole. So it means 22.4 liters leads to 1 mole. Okay, C2H2. Oh, this one not that much important, but I'll just tell later on. So next one is in that oxide. It means gas welding. There are literally 3 types. One is neutral flame. Next one is reduction flame, and next one is oxidizing flame. So first we are just going to see the neutral flame. Okay, most welding is done by neutral flame. It is chemically neutral and neither oxidizing or carbonizing. It means the metal being welded, so does not react with the workpiece. Yes, definitely it does not react with the workpiece material. So you can see here blue flame is considered just 1200 degrees Celsius only, but why see the white cone, it's about 3100 degrees Celsius, more than 3000. And you can see the ratio of oxygen as well as carbon, it means carbon, it means acetylene, it's about ratio is 1:1. It means for example oxygen we just give 1 kg, means the acetylene also we just give 1 kg, that's it. So next one is oxidizing flame. You can see here higher ratio, it means oxygen we are just giving so much higher, it means 1.5 times, and acetylene you can see just 1, producing oxidizing flame hotter than the neutral flame. Okay, it's about 3300, there it's about 3100 degrees Celsius, but here you can see 3300 degrees Celsius. Okay, so you can see the white cone is so much, it means the, how to say, mean the white cone is not that much bigger, it is so much narrower. So that's why the, as the thing, it means as the white torch is so much narrow, the welding, it means the temperature will be so much higher. To weld 2 copper rods, you can see in to weld 2 copper rods in copper, heat dissociation is very large. Yes, definitely, because copper disappears the heat so much quickly. So to weld in a short amount of time, we use this type of welding, it means oxidizing welding. So used when welding carbon, it means copper and copper alloy, but harmful when welding with the steel. Yes, definitely, because while you are just welding with the steel, the carbon goes out easily. Okay, because oxygen, it means since it's been more oxygen, the oxygen reacts with the carbon that is present in the iron and steel, it means okay, steel. So due to that the carbon goes out easily. So that's why for certain kind of thing the oxidizing flame is used, and for certain kind of thing the oxidizing phase is not used. Okay, you can see steel especially nuts and bolts, like so thermal flux stainless steel, but the proper thing is without telling it's a stainless steel, we need to tell it's a alloy steel. Okay, next one is decarbonizing. You can see in iron as well as carbon. So while we just give excess amount of oxygen, what will happen, the carbon gets converted to carbon dioxide and the carbon tends to go out. And steel, it means whatever we get the amount of steel, it's entirely waste product. So steel become waste if excess of oxygen is given. So don't use this for the steel. Okay, copper. So next one, copper is good because of oxygen as well as carbon. Copper, it means why we are just using this kind of oxidizing phase, especially for the carbon, means it means especially for the copper, means because they have a high thermal conductivity as well as it doesn't react with the oxygen so much quickly. So copper is generally used for coating to prevent oxygen. Okay, that's why suppose we just see any kind of water bottle, means we generally coat the copper around that area. Okay, so next one you can see definitely one, the melting temperature will be, and later on after melting the latent temperature will be, and after that the welding will occur. Okay, I think so you're getting the point. So next one is carbonizing flame. So you can see this is kind of reducing flame. Okay, here you are just using more amount of C2 and H2. Okay, you can see C2H2 is so much and oxygen is little bit lesser. So, but in this only before thing only two stages will be there. One is the blue flame and next one is the white flame. But here the three flame is there. You can see the blue flame will be as well as the inner flame will be as well as the white cone will be. So in the white cone only C2H2 plus of oxygen. In the white cone only the proper concentration will be there. And next one you can see carbon, excess carbon comes out and reacts with the oxygen and it forms with the other product. And finally it means the blue color is for carbon as well as the hydrogen. Okay. So you can see this one, carbon monoxide and carbon dioxide. In the excess fuel, it means it decomposes to carbon and hydrogen, and the flame temperature is not greater than 300 degrees definitely. So neutral flame is 300, it means 3100, and the oxidizing flame is about more than 3300 degrees Celsius. But this it means carbonizing flame is less than 3000. Okay. So where it has been used, you can see flame of these types are used in welding, mono. It means nickel and copper alloy, as well as the high carbon steel. Because the carbon content is so much higher, so even though we just heat the steel, it's not a bigger case scenario. And some alloy steels as well as applying hot facing material. Okay. So what is this hot facing material? Let us see. You can see the hot facing material is a special wear resistant alloy deposited on the surface of softener or cheap base metal. Okay. So abrasion, impact, erosion, corrosion is being used. This is hard facing. So done by welding and thermal spraying and overlaying. Instead of making entire compound from expensive hard material, we just apply thin hard layer. Okay. Cobalt based, steel based, nickel based, iron based. It means high carbon, high chromium and high magnesium steels and carbide, tungsten carbide, chromium carbide. Okay, wow. So this is called as high facing materials. Okay. Next one you can see nickel, aluminum and carbon and can react with easily. So it means what are the things that react with the oxygen so much quickly? For that kind of thing we generally use this kind of it means carbonizing flame. Okay. Next thing is you can see for mild steel we are just using neutral flame. High carbon steel reduction it is reducing flame. Grey cast iron neutral or slightly oxidized. Grey cast iron. Alloy steel neutral. Okay, but steel will be mostly neutral. So aluminum slightly carbonizing, brass slightly oxidizing, copper and bronze so you can see neutral flame and slightly oxidizing. Nickel alloy slightly nickel alloy, this one monolith you can see nickel alloy, so nickel alloy slightly carbonizing. So lead is we use the tin. Okay. So next thing you can see why grey cast iron is grey in color, because of the surface there will be carbon, so it is grey in color. If the carbon goes out also no problem, but similarly high carbon steel goes out definitely it is a bigger problem. Yes, definitely, because grey cast iron is a normal thing, so if carbon goes out that won't lead to a bigger complication. But in case of high carbon steel or stainless steel, the carbon goes out it leads to a lot of problem. Okay. So generally the oxygen has been, suppose we are just seeing the oxygen, it is been in the black color, but you can see for the red color means it is C2H2, it means for acetylene gas. Okay, flammable has always been mentioned in the red color. Okay. So you can see solid state welding, it's like a friction. I just told you friction welding, it means melting of metals and we used to join them. Okay, definitely. Fusion welding. Okay, uses and advantage, disadvantage. You can see oxygen fuel welding, it means this one is fusion welding. As definitely no pressure is involved. As definitely no pressure is involved. Filler metal can be welded in the form of wire as well as definitely. So what is the use and advantage? So you can see here flux. Okay, exposure of expense of heat and as well as molten metal to various causes in the flame and was into heat source is definitely. Oh, wait, just one sec. Okay, we can just go with this one. So you can see oxygen acetylene welding equipment. Oxygen is stored in a cylinder at a pressure ranging from 13.8 megapascal to 18.2 megapascal. Okay. Oxygen is stored in a cylinder at a pressure ranging from 13.8 megapascal to 18.2 megapascal. Okay. So it's nearly 1.01 bar. Okay, 10.5. So it is 132. Oh, 138 means it's more than, it means 100 times more than we are just storing in the atmospheric condition. So acetylene can't be stored easily because it is an explosive material. As reference, though, we need to prepare the acetylene instantly each and every day. So due to high explosiveness of free acetylene, it is not stored in a cylinder. So we usually manufacture each and every day. So you can see procedures to store it. Okay, first we take calcium silicate. Okay, calcium silicate, and we pour the acetone, it means acetone gas around it. Okay, and after this this is filled with the acetylene gas. Okay, so later on what will happen, acetylene gas will just fill and acetone absorbs more amount of acetylene gas. Okay, so you can see 1 mole of acetone liquid stores nearly 420 times of acetylene gas. Okay, I think so you're getting the point. So it means you can see 1 mole of acetone generally holds nearly 420 times of acetylene gas at 17.5 bar. Okay, at 17.5 bar only we will just pour the acetylene gas. So while the gas, it means pressure at the total cylinder is being released, pressure drops and means the acetylene gas is released from the acetone gas. So you can see the C, it means acetylene gas is poured, and calcium carbonate, calcium silicate is been there, and as well as acetone liquid is there. Okay, so calcium silicate, it is just a porous surface, is like a sponge. Okay, the acetylene goes out and comes out, it means so much easily. So oxyacetylene welding equipment, you can see CaC2 plus of water, use C2H2, it means calcium carbonate plus it means when you just use the calcium carbonate as well as the water, we get the acetylene as well as carbon monoxide, sorry, it means calcium hydroxide. Okay, so at the time of acetylene release, if acetone comes with, it means at the time of acetylene release, while the acetylene is coming out, if acetone comes along with the acetylene, means the entire flame will be purple color. Okay, another option is acetylene generator. Okay, so another option is we can generate the it means acetylene using the generator. So welding techniques, you can see here sound welding joints can be obtained by proper selection of the torch size and filler material, as well as method of moving the torch along the weld, and as well as the angle of the torch hole. Okay, you can see guys, literally 60 to 70 degree angle is been there for the torch, and we can see the travel is been like this. So in this side 30 to 40 degrees. So this is left hand technique. For left hand technique we are just using 60 to 70 degree, but for right hand technique you can see only 40 to 50 degree is been used. Okay, for right hand technique. So this side the oxygen is between the torch is. Okay, I think so you're getting the point. So next one is, you can see pressure gas welding. So pressure gas welding or oxyacetylene pressure welding. So in this pressure is a process used to make butt joints between the end of the objects such as pipe as well as railroad rails. Okay, the ends of two means materials are heated with the gas welding. But the torch, it means, but the temperature should be below the melting point. Yes, definitely solid state welding, and the two materials is being forced and pushed together under the solid. Okay, so both side we will just heat, and both side after heating we'll just press it, and due to the pressure they get joint. Okay, lap welding, butt welding, so a little bit of different kind of things. Okay, so next one is oxygen torch cutting. Okay, by using the oxygen torch cutting, it means you are just applying excess amount of oxygen. So by using the excess amount of oxygen, we are just cutting the material. So you can see this one, this side we need to cut, means what we'll do, machining, it means next one potting and gasketing. So sometimes you can see this is iron, so melting temperature is 1536 degrees Celsius. So in this type of cutting we convert the iron into iron oxide. So iron oxide is so much easy to melt. Okay, so what we'll just do, we'll heat the surface and we'll just apply means excess amount of oxygen. So in this type you can see we are converting the iron into iron oxide, the melting temperature is just 1000. So you can see this iron 1536, but iron oxide is only 1000. So you can see acetylene as well as oxygen, you can see from here acetylene oxygen, but it's a small pore, excess amount of oxygen will just come. Okay, I think you are getting the point. Oh sorry, yes, this is gas getting as so this is, you can see small pores has been there. So here the, it means acetylene as well as the oxygen comes out, but in the middle area the more amount of oxygen comes out. Okay, this C2H2 at this as far as oxygen, you can see blue flame. So preheats the work to red dot states, and you can see after this the center big hole, this is entirely only oxygen will come out from the workpiece. So as iron FT, it means FP and is preheated and it tends to absorb more amount of oxygen and it just melts easily. Okay, oxygen also burns and white cone leads to cutting of the gases. Okay, the next thing you can see aluminum, it means the same thing we can't use for the aluminum, because aluminum, suppose if it becomes aluminum oxide, means the cutting temperature, you can see it melts around 2700 degrees Celsius. Okay, just aluminum to 660 degrees Celsius melts, but aluminum oxide we generally don't use. So the same thing we can't use also for the stainless steel, because the entire thing, it means the outer section is being covered with chromium oxide. So as a result, outside chromium oxide is that the oxygen can't enter the stainless steel. So gas cutting we can't do here. Okay, So next one you can see metal and metal oxide we will just convert and we will just cut it. Okay, the iron and steel oxidation definitely we heat we use if the carbon is less than 2% we can directly do it. And high pressure yes, definitely high pressure oxygen comes out literally 300 kilopascal is directed against the heated steel plate and the oxygen just burns the metal and blows it away fully. Okay, so for cutting metallic plates the shears are being used. Okay, it means I think so you don't know about the it means shear metal cutting. So by that shear metals are used. So these are used in the it means straight line cutting, and also it means thickness should be 40 thickness. For thicker plate we it means specifically contour and shearing can't be used, so oxy fuel gas cutting is being used. Okay, so next thing you can at the kindling temperature. So kindling temperature means the initiation of the thing. Okay, it means to be particular means wait I'll just show to you. So we can see kindling temperature is known as ignition temperature, the minimum temperature to which substance must be preheated in the presence of oxygen. It means for it to catch fire as well as continuous burning on its own. Okay, so below this temperature the substance may be it means won't sustain the fire. Okay, so it's just it means heating. Okay, you can see for white purpose just 35 degrees Celsius is just it means while it's been reactive while we just pour in dry it reacts, and you can see coal 400 degrees Celsius we need to get, and for paper and wood we need to burn means 200 to 250 degrees Celsius, and diesel is about 210 degrees Celsius, and petrol is about 280 degrees Celsius depending on the composition. So that's why it means sometimes the phosphorus bomb is being used. So just 35 degrees Celsius is important for burning. Okay, so you can see at iron forms iron oxide at 870 degrees iron forms iron oxide. It means 3 times of iron plus of iron oxide. It gives oxygen gives iron oxide plus it gives amount of heat 6.67 megajoules per kg. Okay, for 1 kg it gives 6.67 kg. Okay, it means while you just add the iron and oxygen, and so this amount of heat is being given outside. Okay, so this thing. Okay, and kindling temperature is the time to start the burning. Okay, and for complete oxidation it means this much amount of oxygen is being required. This hole we need to cut means generally simply we cut the two sides and center will fall on will definitely. So due to unoxidized metal blows away the actual requirement. Okay, torch tip held horizontal vertical. Okay, so torch portion 1.5 to 3 vertical. Okay, and here you can see some of the drags has been there. Okay, little bit of drags. This is due to the oxygen flow, and the line becomes it means the line becomes curved called curve. Okay, the drag lines shows the characteristics of movement of oxygen. So if it's more drag means the movement is so much higher. So drag is the amount by which lower edge of the drag line trails through the top edge. Okay, so if it's been looked at straight line means the cut is good. Okay, negligible drag, so much little amount of drag. Okay, torch 2 speed moves means bottom doesn't have sufficient heat to produce a large amount of drag. So it means for example we are just moving the torch so much far means this drag it will become so much like this. So it doesn't have the capacity to it means to weld properly. So that's why it leads to a lot of complicated issue. So torch moves slowly, large amount of slag generated and produced as definitely. So each and every time the travel should be medium. So if it moves so much slowly means it leads to problem. If it moves so much fastly also it leads to problem. So gas cutting is most useful for thick plate as definitely. For thin sheet less than 3 tip size should be small as definitely. If not then torch should be inclined to 15 to 30 degrees for good cut. Okay. So you can see application used for materials which we easily oxidized and the oxidized having low melting points than metals as definitely. Widely used for ferrous as definitely. This kind of it is where it is. Yes, this kind of cutting process, this kind of oxygen torch cutting process, we generally use for ferrous metal. Okay, not 100% widely, but just we are using. So can't be used for aluminum, bronze, and stainless steel material which resist oxidation. So materials which can't be cut by gas cutting, we are using plasma cutting. Okay. So the next thing difficulties you can see if metal temperature goes beyond lower critical temperature, the structure transformation occurs in overfreeze. So final microstructure depends on the cooling rate. Steel with less than 0.3% of carbon has no effect. So for high carbon steel, materials around cut becomes preheated separately. So we are just preheating the material and may post it also necessary. So cutting of cast iron is also difficult because carbon is present. Okay, it means chromium and nickel is present in the ferrous alloy. In oxidation becomes difficult. Okay. I think so you're getting it. So okay guys, let me see in the next video. And then tata, bye bye, have a good day.